What if I told you there was a way to know if your physics answer was wrong before you even finished the calculation? No, it's not magic. It's a technique that will become your ultimate safety net for every single exam you'll ever take. It's called dimensional analysis. See, in physics, the math isn't just about the numbers. It's about the very nature of those numbers. Think of it like a secret language that reveals the deeper truth behind every equation. To understand this, we first need to get something straight. The difference between units and dimensions. It sounds a bit technical, but it's super simple. A unit is a specific way we measure something like meters, feet, or even light years. But the dimension of all of those is simply length. It's the fundamental quality they're all measuring. In physics, especially when we start with mechanics, we mostly deal with three fundamental dimensions. We use a capital L in square brackets for length, a capital M for mass, and a capital T for time. So whether you're measuring in kilograms or pounds, the dimension is just mass, or M. Whether it's seconds or centuries, the dimension is time, or T. These three, L, M, and T, are the building blocks for almost everything we'll encounter. Now here comes the single most important rule in all of physics, the one rule you can never, ever break. You can only add or subtract things that have the same dimensions. It's that simple. You can't add 5 meters to 10 seconds, it's complete nonsense. What would the answer even be? It's like trying to add apples and oranges, it just doesn't compute. You can add 5 meters to 10 meters, sure. You can subtract 3 seconds from 10 seconds. But you cannot mix and match dimensions when you're adding or subtracting. This seems obvious, but it's the foundation of everything. And here's where it gets really powerful. This rule leads to an even bigger idea. For any valid physics equation, the dimensions on the left side of the equals sign must match the dimensions on the right side. They have to be identical. If they don't match, your formula is 100% unequivocally wrong, no exceptions. This is the ultimate error-checking tool. So how does this help you in an exam? Imagine you're stuck on a complex problem. The pressure is on, and you're staring at a formula you wrote down, but you can't remember if it's correct. Is it supposed to be force equals mass times acceleration, or maybe mass divided by acceleration? Instead of panicking, just check the dimensions. Force is measured in newtons, which fundamentally breaks down to mass times acceleration. So the dimension of force is m times, light squared. On the other side, mass is m, and acceleration is L squared. They match. So F is correct. What if you thought it was mass divided by acceleration? That would be m divided by L squared. That clearly doesn't match the dimension of force. You've just instantly proven that formula is wrong without plugging in a single number. This is your safety net. If a problem asks you to find a distance, your final answer must have the dimension of length, L. If you go through all your calculations, and your final result has dimensions of T squared, you know you've made a mistake somewhere in your algebra. Maybe you forgot to multiply by times squared, or you divided when you should have multiplied. This built-in error checker tells you to go back and fix it. It turns a potential 0 on a question into an opportunity to find your mistake and get it right. Mastering dimensional analysis does more than just help you catch errors. It gives you a deeper intuition for physics. It lets you see the skeleton of an equation and understand its structure before you even think about the numbers. Sometimes, you can even derive the form of an equation just by thinking about the dimensions of the quantities involved. It's a skill that separates the good students from the great ones. It boosts your confidence because you're no longer just blindly plugging numbers into formulas you memorized. You're actually understanding the relationship between physical quantities. You're thinking like a physicist. So, spend some time with this. Take your formula sheet and check the dimensions of every single equation on it. See how they all work. Practice breaking down derived units like joules for energy or pascals for pressure into their fundamental dimensions of M, O, and T. The more you do it, the faster and more automatic it will become. It's a small investment of time that will pay off massively throughout your entire physics journey. Now that we know how to check if our formulas are even correct, there's another crucial aspect of measurement we need to discuss. How precise are our numbers, really? In the real world, no measurement is ever perfect. There's always some uncertainty. So how do we handle that in our calculations? In the next video, we're going to tackle significant figures and error analysis. This is essential for anyone who wants to do real science or engineering, because it's all about understanding the limits of our knowledge. Thank you so much for watching. If this helped you see physics in a new light, make sure to hit that like button and subscribe so you don't miss the next video. See you then.